Hi guys, and welcome back. Hope everyone's doing well. So what we are doing today is 5.5 law of sines, but we're going to do a few word problems. Now these word problems aren't necessarily difficult, especially if I give you a picture, because it's just solving a law of sines problem. Now if you are drawing a picture, a lot of the ones in the notes I'm going to draw pictures with you. You have some on your homework and some just on practice that you might have to draw your own, but I do give you a lot of the diagrams or start you off on them, at least the more difficult ones. So what you're going to be able to do today is use law of sines to solve for triangles in real-world scenarios. So again, just a reminder what law of sines is. It says, if I were to take the sine of an angle, so say for example angle A, divided by side A, over sine of angle B, over side B, and I could cross multiply. So it's just a comparison between an angle and its opposite side. An angle and its opposite side. Okay? And remember, we are only using law of sines for angle, side angle, and angle, angle, side setup, which is most likely what we're going to see today in this video. Our first example says, a pole tilts away from the sun at an 8-degree angle from the vertical. So vertical, remember vertical just means up and down. So vertical, up and down, right? So that means what are we going to do? Well, we have a pole tilting away from the sun, 8-degree vertical. So we're going to assume, I'll even draw the sun. So you see what I'm getting at here. There's my little sun. And maybe it should have been orange probably, or yellow or some sort. Okay, my very sad, pathetic sun. And a pole is tilting away from it at 8 degrees from the vertical. So that means if it was standing straight up, we're going to tilt it 8 degrees. So I'm going to say this is my pole right here. It then says that it casts a 22-foot shadow. And we talk about this in class, especially when we did some word problems in 4.8 and 4.2. Where's your shadow? So if you were outside, where would you see your shadow? And a lot of you were always telling me I'm going to see it on the ground, right? So this pole is going to cast a 22-foot shadow. We'll talk about the angle in a second. It then says the angle of elevation from the tip of the shadow, so mark that, from the tip, the end of the shadow, to the top of the pole, is 43 degrees. And we talked about angle of elevation. We always said it's from the ground up. How tall is the pole? So let's go back. We need one more angle, but we have information that we didn't use yet. It says in the first line, a pole tilts away from the sun at an 8-degree angle from the vertical. So if this were vertical, which it is, the pole is tilting 8 degrees away. But that 8 degrees is not in the triangle. Well, you can see that's a right angle. So 90 minus 8 degrees is just going to give me not 72, I apologize, 82 degrees. So that means that this angle right in here is 82 degrees. So 8 degrees from the vertical just simply means 82 degrees from the ground. Okay? Now that we have our triangle, and I'll kind of outline it in this color, we're going to say what setup do we have? We have angle, side, and then an angle. So we have angle, side, angle, setup. And what are they asking us to do? They're asking us for the height of the pole, which is going to be this distance right here that I just marked in green. Okay? You can call it X, you can call it P, you can call it T, whatever you would like. So how are we going to do that? Well, you can at this point kind of ignore that 8 degrees if you want. And we are just going to solve for this. So what's the first thing we do with law of sines? We're going to say if we're solving for X, we're going to use the angle across from it. So sine of 43 degrees divided by X is equal to, and then the only other side we know is 22. So we need to use the angle across from that. What's the angle across from that? Well, we can find it. 180 minus 43 minus 82 is just simply going to tell me that that third angle is going to end up being 55 degrees. I did that calculation right. So 55 degrees. So therefore, if that angle is 55, you're going to have sine of 55 degrees over 22. And just like before, we're going to cross multiply and solve, and we will get that x is equal to 18.316 feet tall. Okay? Use a label. We're talking about word problems right now, real world. So like I said, these diagrams are a little hard to draw, some of them, which is why I'm using the one on the notes where we draw together. That way you can try to draw some for yourself on your homework, and I also help you with some of them. Okay? But this is your law of sines, so you should be setting it up so that you can use law of sines. If you end up having two sides at an angle, you did something wrong with your diagram. Okay, next one. Stan, a forest ranger at a ranger station A, sights a fire in the direction 32 degrees east of north. Ranger John at ranger station B, 10 miles due east of site A, sights the same fire 48 degrees west of north. Find the distance from each ranger station to the fire. So the hardest part about this is, let's review, if you were thinking about like a compass, we have north, south, east, and west. Okay? So the first thing I notice, Stan is at ranger station A, and you can put ranger station A wherever you want. I'm just going to put it right here. Just drawing. Remember, you should be drawing a triangle. So law of sines is what you're using it for. Okay? So he's at ranger station A, and he sights a fire in the direction 32 degrees east of north. So what this is saying is if I'm in the north, it's 32 degrees east of that. So towards the east. So he's going 32 degrees towards the east. Okay? So it's a little bit weird to think about. So bear with me for a second. We'll talk about that in a minute. So here's, if this is north, he's going 32 degrees in this direction. And he sights a fire that's 32 degrees east of north. So we're going to say my fire's up here. I'm terrible at drawing, so bear with me, guys. And hold that thought for a second. It then says, Ranger John at Ranger Station B, 10 miles due east of A. So if here's Ranger Station A, 10 miles due east is Ranger Station B. Okay? And we know it's east. East goes to the right, so this is 10 miles away. It then says he sights a fire. He sights the same fire, so he's looking at the same fire. So he's looking in that same direction towards the fire, 48 degrees west of north. So again, if we're at north, he's viewing it 48 degrees to the west. So if we're at north, he's going 48 degrees to the west. Okay? You can see we have a triangle, but we don't have the inside of the angles of the triangle filled in yet. So what are we going to do? Well, we kind of know, we can see that these are kind of 90-degree angles right in here. So 90 minus 48 is going to give us our angle in our triangle, 42 degrees. 90 minus 32 will give us our angle in our triangle of 58 degrees. So let's stop for a second. What is our triangle that we have? Our triangle that we have in green is right here. We have 10 miles at the bottom. We have our two angles, 58 and 42. So our given information is angle, side, angle. Okay? So at this point, what's the deal? What do we do? And like I said, these are the hardest diagrams to draw. I didn't really give you guys anything like this to draw on your own, but since we're doing it together, I figured it wouldn't be too bad. What we're going to do now is see what are they solving. So we want to now find the distance from each ranger station to the fire. So I'm going to call them X. I want to find this distance, and I want to solve for Y, which is the other distance. Okay? How are we going to do it? Well, I'm going to use law of sines, of course. This is basically solving the triangle. We're solving the two other sides, and we're going to need that third angle. How do we find the third angle again? 180 minus 52 minus 58 minus 42. So 180 minus our 58 minus our 42 is going to get us that our third angle is 80. Why are we going to need that? Because our only given side is 10 miles and the angle opposite that is 80. I'm going to pick a side to solve for first. I'm going to solve the distance from the ranger station B to the fire first. I'll solve for Y first. Doesn't matter if you solve for X first. So I'll have my given information. Sine of 80 degrees over my 10-mile side is equal to, now if I'm solving for side Y, I want to use 58 degrees because it's opposite it. Sine of 58 degrees over Y. If you cross multiply and solve, you'll get Y is about 8.61 miles. And I don't specify how to round. Our last one for this problem, now we have to solve for X, which means we're going to instead of using Y and 58 degrees, we're now going to keep the left side of the equation the same. Sine of 80 over 10 is equal to sine of the angle opposite side X is 42. So it'll be sine of 42 degrees over side X. Cross multiply and solve, and you'll get X is about 6.79 miles. Again, no real way to check yourself here, but you can say, okay, 80 degrees is the largest angle, opposite that is 10 miles, largest side. Makes sense. Smallest angle is 42 degrees, opposite that, side X should be the small side, and it is. So it kind of makes sense here. This would be a problem to go through, check my worked out solutions, and make sure you understand kind of what I'm doing for this one, especially when it comes to using the law of sines. The diagram, like I've said, is difficult, but if you can get the actual using the law of sines down, you'll be fine. Okay, and last but not least, we have one more, which this one's not bad because you can see the diagram is pretty much given to you. It says Angelina is looking at the Big Dipper through a telescope. From her view, the cup of the constellation forms a triangle that has the measurements shown below. Use law of sines to determine the distance between A and C. So they tell you what side you're finding, they give you the triangle, and they tell you what you're going to use. You're going to use law of sines. So again, I'm just going to draw my triangle a little bit bigger at the right. 95 degrees. Remember, none of these are really drawn to scale. 40 degrees and 2 inches. So you can see that this is an angle, side angle setup. And what am I going to do? Well, it wants me to solve for side AC. So you can call it X or you can just leave it AC. That's up to you. And how am I going to do that? Be careful here because the triangle is a little obtuse. Make sure that if you're using 2 inches, you have to use angle C across from it. Okay, be careful with the opposite side, opposite angle. If the triangle is drawn a certain way, it can look confusing. So we're going to find the third angle. We get that third angle is 45 degrees. Remember, subtract from 180. So what we're going to do is we're going to solve for side X, I call it, or side AC, which they're telling us to find. How are we going to do that? If we're solving for that side X, we want the angle across from it, which is 95. So we'll get sine of 95 degrees over X is equal to sine of 45 degrees over 2. Remember, you can only use the given side. I can't use this other side over here because I don't know what it is. And now we're going to cross multiply and solve. If we do that, we should end up getting that it's about 2.8176, and I believe we are in inches. Okay? Now, remember, this isn't the actual length of the constellation. It's just on a telescope. So it's small. It's in inches. It's not going to be in miles or anything huge. And this makes sense. So what you guys will have is you'll have a few word problems tonight, and then I believe I have a quiz for the next class period. It's going to be a quizzes set up. You get, 5 to 15 minutes per each problem. Very basic, very straightforward, exactly what we've been doing on our examples and everything in class. Good job today, guys.